Okay. So welcome everyone. Today we're going to be going over testnet smart contract. You see that this is the second of 4 sessions. Last week we talked about the fundamentals, and then we have testing and front end left. So this session topics, we're going to go over smart contract overview. We have a workshop on counter contract and resource. We have 2 hours, so I'm going to try to, go over the theory in about 30 minutes and then, take a break and then we go to the workshop. So testnet contract overview. So testnet smart contract. So testnet smart contracts are programs that run on the testnet OS. The smart contract can access testnet persistent state through the operating system. So this, I just have like a dichotomy of, what the smart contract looks like. So yeah, we write smart contract in Cairo. Some of you might have started the, Stacklinks and you should have gotten exposure to Cairo. So one of the application or major applications that is presently used, Cairo is presently used for is writing smart contract, right? And this is kind of like an high level. So we have the code, which is written in Cairo. It's compiled to Sierra. And then we generate ABI or, this contract dispatchers, which will tell us like what functions are accessible. And we also kind of use the contract class. So once we want to deploy a smart contract on the Stacknet, we need to first, declare it and then deploy it. So when we declare it, it generates a class hash, and that's like the blueprint of the contract. And then we can use that class hash to deploy the contract. And every time we modify this contract, and you would see kind of like an example today in the workshop, the class hash changes. We use that again, we use the class hash to deploy the contracts. And then I'll quickly go over the basics. So yeah, you should see like an example of what a basic at the base level, what a smart contract look like. So a smart contract is a Cairo module. So you'll see this module counter contract. It's annotated with a Stacknet contract. So this attribute, yeah, it's really important. So we need to mark it Stacknet contract. So the compiler can use this to, generate other functions that we can use to know that this is a contract. And the contract always have to have a storage. So this is an example of how you write like a custom type, struct, and the name. But in this case, we have to write struct and storage. And then we have to use the storage attribute to let you know that we have this. If you try to compile this, the compiler is not going to throw an error and it should compile. Obviously, you need to have more for it to be like a full-fledged contract, but this should compile as a contract. Then we go to constructor. So constructors are functions that are run only once at deployment. They have to have a name constructor and they have to have the attribute constructor annotated. You would see that most times we use ref self, contract state, and then we put the arguments we want to pass. And it's just used to initialize the state that we want, once we deploy the contract. In this case, we have counter U32, and then we have the self.counter.write initial counter. This is what we're passing in. And you'll see that you're saying counter.write. Once you have the counter as a variable in the storage, it automatically generates like functions like read and write is one example that you can use to kind of like modify the contract state. Going to exposing function. I'm just going to quickly check the chat if there are any questions before I keep going.
Yeah, no questions for now.
Okay, no questions for now. All right. Again, if this looks, a bit foreign, it's fine. We're going to kind of go over it during the workshop, and you can ask more questions at that time. And if you have questions, you could please leave in the chat.
Yeah, Kai's going to write this live from scratch soon.
Yes. Exposing function. So you will see that this implementation block, we have this IMPL keyword, and then the counter contract. This is the name we want to give our contract implementation of super. And this is kind of like we are accessing the iCounter interface, and we're going to go over interface shortly. But what you need to kind of notice is this attribute, the ABI embed v0, is just stating that every function in this implementation block is a public function. So it's a public function. And then you would notice that there are mainly two types of public function. There's the read-only function, which is view. It takes a snapshot of the state as parameter, and it's free. So again, how you're going to know this is a view function. It takes in self and a snapshot of contract state. And reading from this is free. So you don't have to pay to, call a view function on the contract. And then you would see the other one, which is a write function. External, it takes in mutable reference of the state and it calls gas. So again, it has a ref self here. This keyword ref self is going to be a mutable, it's going to mutate this contrast state. And then we can read here. So the ref self exposes like the read and write too. So this here we're using the self.counter.read to read the state. And then we're using self.counter.write to modify the state of the contract. And again, because we're modifying the state of a contract, and it's an extra function, it's going to cost gas, so you're going to pay for this. Okay, and all public functions must have the self as a first argument. Like you will notice that we have the self here and the self here, so this is essential for it to be a public function. And then we go to the interface. So this is an example of what a Cairo interface, StackNet smart contract interface looks like.
Sorry, okay, can I, there's a question.
Okay.
Could you expand more about why sometimes the ref self and sometimes the self? Chinonso was asking that.
Okay. Ref self is just stating that we're going to modify the state of the contract. So you see this write function takes in a mutable reference of the state. So ref self is like stating that this is going to be a mutable reference and we're going to modify the state. Why this self at is taken in a snapshot and it's not going to modify the state. So it's just going to be reading from the state. I hope that answers the question. And if it doesn't, when we are in the practical hands-on workshop, I'll show you a better example in that case. Do you have a follow-up question?
No.
Okay, awesome.
Thank you.
Okay, this is an example of a contract interface. You notice that this has a StackNet interface here. So if you remember for the contract, it has a StackNet contract here. In this case, the attribute here is StackNet interface. You're just saying that, okay, this block or this in the scope, we are going to be writing an interface. And then we have the trait. You don't have to use I, but conventionally, most people use I, just the interface and the counter contract. And it exposes the blueprint of what is going to be implemented, and we can use this to also interact with it from other contracts. It says it's used to standardize our contract call. It's not mandatory, but again, it helps in better integration with other applications. So again, this is a trait, I counter interface. Again, you have the T contract state, and then you have the functions that you want to, implement. You would not have to write the implementation here. You just have to write the function signatures. So in this case, you have fn function get counter. That's the name of the function, and this says self at T contract state. Again, this says that this means that it's a view function, and it's not going to be modifying the state, and it's going to return a U32. And then the next one is the fn increase counter. And it's taking a ref self, it means it's going to modify the state. It's mutable. It's going to mutate the state of the contract. That's the interface. Then there are explicit interface. In this case, we're explicitly stating that, okay, this is the interface, pub trait. We have the interface, T contract state, and then define it. It has the state StackNet interface attribute. This is the contract. And then we are implementing it. But again, we explicitly defined it in this case. And this, we also use the ABI embed v0, which says that every function in this implementation block is a public function. So we're going to be able to kind of interact with it from external agent up. And then we have the implicit function. In this case, you'll see that we did not, like compared to this place where we explicitly stated the interface. In this case, we are not doing that. We have the StackNet contract, pub mod, because again, the contract is a model. So again, pub mod, and then you have this interface contract. You have the storage, which is essential. Every contract needs a storage. We put the attribute here, struct storage, and then put the value. And then we use the generate trait here, and then we have ABI per item. So this is going to interface for us, so we're not having to state it. And this comes in helpful, to reduce like a lot of boilerplate in the code. And then we have to, because we have the ABI per item, we have to explicitly state that, okay, this is an external function, this is an external function. That is the example here. And then I'm going to go to event. I'm still going to check now if there are more questions. I don't know. Okay, no questions. We go to the events. Events is a way that events are custom data structure emitted by smart contract during execution. This is a way you can use, the contract can use to communicate with the outside world, right? So when like something or an action happens on chain, you can trigger an event and then it emits this data or the custom data that you've defined here to the outside world. And how you define events, you use the event macro. Now you use the event attributes, and then you have the derived drop and the StackNet event. And it's an enum, which have multiple variants, right? So this one has one variant, which is the ownership transferred. And then you have a struct that you're using to define what the ownership transfer is. And then you have a key here. You can also use an enum also to define this. But yeah, this is kind of like example. We're going to use this during our contract today, so this you should be able to see it in practical terms. And then contract call dispatcher. So once we create an interface, right, it automatically generates dispatchers, which these dispatchers you can use by other contracts to interact with this contract. We have this here trait iData. It should generate like iData dispatcher and then the trait and the library. Dispatchers are automatically generated from interface. Using a dispatcher, the function is executed with storage context of the targeted contract. So yeah, you can use you're going to see an example. Probably I will show you an example during the class. But yeah, maybe you want to interact with an ERC20 token within your contract. This would really come in handy in that case. And then we go to components. So think of components like Lego blocks. And they are very similar to contracts, but the only difference is that you cannot declare or deploy a component. You would see that, again, it has the StackNet interface, so it's very similar to what you would have in a contract. But also you will notice that in this case, StackNet components, if it was a contract, it will have a StackNet contract attribute, but this one has a StackNet components, yeah. But it also has a storage, it has events, and you can also have an implementation block here. The main difference is that you cannot declare and deploy it. You can, however, use it to write, code that you want to kind of use in other contracts. So components are modular add-ons containing functions, storage, and events. Can be implemented in multiple contracts, cannot be deployed or declared, and it becomes part of the contract's bytecode.
Sorry, there's a question in the chat.
Okay.
Why do we have from Oladele is asking, why do we have the derived drop sometimes, like in the event, for example, or in the struct?
This is a part of because Cairo uses like a ownership model, right? This like immutable model. If once these code block fall out of scope, you need to put a drop there so that it should know that it drops it. That is the best way I can explain it. I don't know if you want to add to it, David.
I mean, it is memory management, right? Once the thing gets out of scope, it needs to be destroyed and removed from memory. That's why it's there. So it needs to know how to remove it from scope or from memory.
Yeah, Yeah, and that is why we use the drop here. And then the stack event just kind of like have it so that we know that's StackNet event.
Okay, Casey's answered the question. Cool. Cool. You can continue.
Okay. Then I'll go into example use case of smart contracts. So there's so many different use cases of smart contracts. You would see, use it for DeFi, build on-chain games with like Dojo. Dojo is like a framework. I compare it with like React and Next.js. So Dojo is like a framework on top of Cairo that we can use to build games. And this is like one application of, smart contracts. There are a lot of games that are being emerging on StackNet. There's games like Influence, Realm World, which should be launching their new season in about a week. But yeah, then there's the governance use case for smart contracts. There are a lot of projects in the like Web3 ecosystem, like Aragon. I know there's like Snapshot and different other projects are into governance. And if you want to kind of like, experiment with governance on chain, I guess smart contracts is like the best way because of, immutability and transparency of it. The wallet use case, you can build wallets. StackNet, for one, applies native account abstraction. So there's a lot of like custom logics you can build on top of this. Cartridge is one Cartridge is one player, the building wallet on StackNet, and they're kind of like, building session keys to improve the user experience, and people can experiment a lot with, wallets with smart contracts, and then royalties, decentralized identity, and there's like much more. I will pause here and kind of like, wait for questions. David, if you want to add anything to like, the use cases of contracts, or, Casey, I kind of like want to hear your opinion. Yeah.
Casey was giving some good examples about custom data types on a smart contract. Normally I think about something like a person with a name, with an age or something, but Casey said it could be even a musical note. So it can be really anything you can represent as a custom data type. So no, nothing more to add. I think we can just this is next is the live coding, or what's next after
Yeah,
this?
next is the live coding. I was trying to rush it up so that we have enough time for the live coding. I actually had planned like a break before the live coding. But the class has been going for like 16 minutes now, 17 minutes. I don't know if it's too early to take a break, but the next
Yeah,
step is
it's too soon. Let's do the live coding and then just stop somewhere in the middle. So I think there's no need to rush. We're going on time.
Okay, awesome. I will get to the live coding. So now we're going to the workshop, counter contract with access control. I just show a slide on dependencies. We do have like ASDF, which is kind of a recommended way if you're trying to set up your StackNet development environment on your local machine. You use ASDF. In this class, we're using a container or Docker. But if you're not using Docker, this is probably the most recommended one way to kind of set up your environment. Then there's the Scarb, which is a Cairo package manager. If you are coming from like maybe maybe Python space or Rust, you're familiar with like Cargo. Scrap is the way we use to build, and now we have like a scrap.xyz, and we're going to show you an example of how we have like a remote repository where we can pull StackNet code from. Then there's the Foundry. It's good for testing, and just assist you in writing contracts. Then we have Rust. Rust is because again like StackNet or Cairo depends a lot on like some or has a lot of some dependency that requires Rust. So we install this. You don't need to know Rust to use Cairo, but to build properly, we need Rust installed. And then there's the VS Code extension that helps you with syntax alighting and just helps you make your Cairo development experience better. So this is it if you're using VS Code. And then we'll go to live coding. So if you were following from last class, you should be able to still follow along. I'm going to leave the repo in the chat so you can clone it if you want to. So I just left it in the chat. I'm going to go open up my terminal, and then I'm going to clone the repo. So I'll do a git clone, and then a Basecamp 11. So I have that. I'm going to open it with Cursor and Basecamp 11.
Question from Martin. Is the compiler of Cairo written in Rust?
I believe so, yes. Okay. No, if anybody is trying to follow along, just leave a yes in the chat to let us know that you've downloaded it. If I get like a couple of yes, I'm going to get started. But you should be able to like clone the repo. Okay, Akim said yes. Roman said yes. Diego, yes. Awesome. Okay. Okay, I got a couple of yes, so I'll get started. So the first thing I'm going to look at is the dev container. In this case, we want to update it to the latest that just got pushed today, which is going to be 2.9.1. So I'll do it 2.9.1. I am going to go to the scarp.toml file, and then I'm going to update it accordingly. So we have StackNet as a dependency. We need it to be 2.9.1. We also upgraded the Foundry, so we're going to do a 0.334.0. And then this assert macro would also be 2.9.1. So this is what you need to change from last week. And then you should be good. In my case, there is like this icon at the bottom left. I click on it and I should be able to see an option to reopen in container. So I'm going to do that.
If you're using VS Code, you also have similar options as well to use dev container because I think Cursor is based on VS Code, right?
Yes, cursor is based on VS Code. Okay, so did that. For some reason, my Cairo extension doesn't come with the so we have to like manually reinstall it. So I'll just click on it and it should reinstall the Cairo extension. So I just did that, and then I should go back to my base. Just to confirm, you know what, I'm going to do a switch. Give me a second. I'm going to do a git switch to the StackNet Workshop repo. And the only difference here is that I have a to-do here to show what we're going to do, my steps. But yeah, everything else should be intact. Just verify. And in this case, we have a lib, which is empty right now. So the first thing is I want to create a module. In this case, I like to put it in like a folder. So I'm just going to do a CD. I'm going to CD.
Can you increase the
In,
font size one more?
okay.
Yeah,
Is
perfect.
it better now?
Yeah, it's good enough.
Or should I zoom it one more? Is
That
this too
looks
much?
great. That
Okay,
looks great.
awesome. Okay, I'll do that. So if I do a ls, I should leave the Cairo. In this case, I want to create a directory. So I'll do a make directory for counter. And then I'll also cd into this directory, and then I'll touch counter dot Cairo. So if you open this, you should see counter.cairo inside this counter folder. And in this lib.cairo, I'm going to just say mod counter. And then inside it, I'm going to say another mod counter. So it just kind of find the file path. Okay. And I have a gist. I'm going to send it to y'all. I did this to save time, but I'll still share it with y'all. So this is the gist. I'm going to just copy from there. So we can have kind of like a starting example. And I'm going to explain what I just copied and pasted. Okay. All right. So again, you would see if you follow with the gist, you should be able to see what I got here. So this is the StackNet interface, which I have the traits I counter, and then as a T type, then I have one function here, which is the get counter. It's a self and taking a snapshot of the contrast state, and it's going to return a U32. I dropped it with the panelists. Give me a second. I'm going to drop it with everyone. Yeah, that is the gist. Okay. Okay. Also, we'll see 3 more functions, but I commented it out right now. I'm going to implement them by uncommenting and implementing them. But yeah, we have the increase counter, we have the decrease counter, and we have the reset counter. And the 3 of them reference the state. And so they are going to modify the contrast state. Then we have the code block, the mod counter, which we have the StackNet counter contract here. So again, we need to put this attribute in our model so that the compiler can know that, this is a StackNet contract. In this case, we use a use super I counter interface. So we're just importing this counter into the scope of the counter. I counter into the scope of the counter. We have a use StackNet contract address. So we're importing this dependency, and then we're using the storage, which has a storage pointer read access and pointer write access. And this will help us in like writing to the state and modifying the state. We have the constructor. Again, remember that, constructors are, functions that run only once when the contract has been deployed. So in this case, we have it named constructor. We have nothing implemented yet. We're going to implement it in this example. And then we have the ABI embed v0 and the implementation counter implement of iCounter. And then we're good to go. You see that the compiler is making noise right now. It's saying not all items are implemented. It's missing the get counter. Because we have the get counter uncommented, but we did not implement it yet. We commented it out. So I'm just going to uncomment it, and you see that there's no more crying from the compiler, which is also a good thing because it can help you kind of like debug the code better. But in this case, we have the implementation, which is just a function get counter. Self is taking a snapshot of the contrast state, returning U32. And then it says self.counter.read, which is a U32. So because we did not put this here, it's going to kind of return the result of this output, which is a U32. I'm going to run a scrub right now and try to build and see. Let's keep our fingers crossed and see if this works. It takes a while, so I'm just going to try uncomment it, and maybe we can start implementing some things while we wait for the compiler. So in this case, we want to initialize a value for the counter once the contrast is deployed. So we just put it here as an argument to the constructor. We can call it initial value of type U32. And we're going to have a self.write counter, again, .write. And then we'll put the value that we want, which will be initial value. And then this should be fine. Give me a second. Let's just see if compiler is still building, so we can continue. Language crashed. I'm just going to close this. So the next thing is we'll try to implement another function. So this one is like the increase counter. So I'll just uncomment it out. And this should, start complaining in a bit. I think the language server crashed, so it's not, but okay. So we say, we can just copy this and then paste it here. And then just modify this to contrast state. And then we implement it. And in this case, we want to increase the counter. So again, because we're using ref self, it should expose the read and write. So we can, create a variable here, which might be old counter. And then we can do a self dot counter dot read. So we can get a value, and this read doesn't need any arguments passed to it. So we just do this. Then we can, maybe create a new, so let new counter equals self dot counter dot right. And then put in the value. So it'll be old counter plus 1. So we're incrementing it by 1. If we take out this storage access, it should complain. Okay, so we add an error here. So I'm going to just do a scrap clean. Not sure why that error came up. And then build. Here, wait for this to build. Let me just try to see if I can read this error message. I know some people are complaining about access. This can be related to that. Okay, good. Well, it's working accordingly now. So yeah, it's complaining because I uncommented this out. So I'm going to comment out and then try to run the build. And this should work fine now. Okay, unused import. Gonna compile. There's an error in the workspace. Skip token. Where's that counter contract? I have a token. Line 35. Okay, we have a token here. So again, this is a scrap build. This should work fine now. It's just complain about some unused variable, but this should build fine. So it's finished building and it should work. I'm just gonna check in if anyone is following along.
A
Diego
couple of
says,
questions. Yeah. Yeah, I'm gonna read it. So Colin's asking, can you show the new version of the scrap.toml, the upgraded one?
okay, so maybe you're saying scrap-v. I'm using 2.9, and if you go to my scrap.toml, you should see 2.9.1, which is StackNet version, and then I have 2.9.1 here.
But also you modified the standard founder, right? To 34.
You said what? Yeah, I upgraded the
Also,
foundry to 0.34.
Nico is also asking to show the lib.cairo. What happened there? Those imports.
Okay, so in the lib.cairo, I am in mod counter, so this folder, and then I'm pointing it also to this counter here. So this just helps the compiler to register where our files are, and it's gonna be helpful if you're trying to import maybe this contract in another file.
Now,
But
why the folder? Why not just having the counter.cairo file next to lib.cairo?
we can also do that. So in this case, I can also have so I can just do this here and touch counter.cairo. And yeah, I can just have a mod counter. And so in the lib, I just have a counter. Yeah. This should also be a valid way to
I
implement
mean, you
it.
can just paste the code directly in counter.cairo, right?
Yeah, I can also paste the code directly in counter, but this just helps you kind of like put every logic in one place. But I can do that if that helps. You know what? Let me just do that. So it's so we don't have to kind of go there. So this also would work. Although it's build. But like once you're building like big applications, you should kind of like know how to use the file path. That's why I implemented it. But yeah, I just moved it to the lib if that would help people follow along.
Yeah, it's just a matter of taste where you want to put the code. Usually, it's good to break things into smaller parts, so different files for the specific purposes.
Mm-hmm.
And for example, you can use the code directly in lib.cairo, or you can put the code in counter.cairo and then lib.cairo just pretty much import counter.cairo into scope. Or you can create a folder if you want to have multiple files logically grouped into something counter. So you have multiple options. It's part of the, let's say, resolution of modules in Cairo.
Exactly. But yeah, I just moved it to the lib.cairo. It will be easier to help a lot of people follow along. Um, is there any other question from here? Okay, so this should answer Diego's question because I moved it to lib.cairo. JK Yellow is following for sure. Emmanuel following, but not coding at the moment. Okay. Is there another question before I move on?
You can move on. I think that's the only big question.
Okay. So we just implemented the increase counter. We're going to implement the decrease counter too. In this case, we can just say fn decrease counter, and then again we're referencing self contrast state. So we're referencing contrast state, not contrast address. And yeah, we're going to write implementation. We could just copy and paste this one. Paste it, and then we just subtract. And one simple hack here is if you kind of want your contract to be properly formatted, like see this, maybe this is like in this case, you can just run a scrap format and it should run and format it. Okay, for some reason this is acting up, but a scrap format should format it. But fail to save the kernel files near. Please compare version. Okay, I'm going to save this. Okay. Just overwrite that. Yes. Okay, this should work this time. Okay, so I've implemented the decrease counter. I'm going to also implement the reset. So in this case, I could just fn reset counter and a function name, and then we say we're going to reference the contract state again here. So contract state, and in this case, we are going to be we're going to be resetting it back to 0, right? Initially, okay, so in this case, we are going to be resetting back to 0. So we can just call a self.count counter. Again, we're going to be writing to it, and with the value, again, we're going to just put it back to 0, yeah? So if this function is called, it should reset the counter to 0. We can, again, go build again and see if we are all on track. It's still going to complain about the unused variable. We're going to use it, but everything should compile fine. Can anyone else that's following just kind of give a thumbs up that, they got it to this level, or if they have questions, I can answer that. Okay, thumbs up. Okay, awesome. Okay, so we have the basics here. We have the get counter, we have the increase counter, we have the decrease counter, we have the reset counter. I have what to do, so we have that. So we want to have this contract emit event, right? In this case, I'm going to just reference the Cairo book because it seems like we have more time, so it would kind of like help us kind of understand.
Okay, so a couple of questions, sorry, in the chat. Hakim is asking, I miss when you created the contract state class. Can you show what that is like currently? So what is a contract state? I think that's the question. Because we have a type, but we never define the type anywhere.
Yeah, this is inbuilt. So this is coming with the StackNet compiler and the StackNet. So with this, when we imported StackNet as a dependency, it comes with a couple of things, and one of them is contrast state. So contrast state just includes like what is in the storage variable. Yeah. So we're saying the contrast state, which one of the state that we have here is the counter. But we don't need to explicitly import contrast state. It is in our StackNet smart contract dependency or StackNet dependency.
Yeah, that type is created on the fly as a result of the meta programming. As a result of defining that this module is actually a smart contract. So that's why you don't have to define it. That's why you don't have to import it. The compiler on the fly will create it and inject it into those functions as the first argument. Alexander says, I'm just a bit confused because when I move my code to the lib.cairo, now it starts to highlighting a lot of things as errors. Um, we might need to help you out on Discord because you will have to share some code. Hard to help you out just by reading that. Uh,
Um,
Just
yeah.
real quick, are you sure that you've like copied the first character, like that first hash? Sometimes, like when you're copying pasting, just
yeah.
check the boundaries, because sometimes that can cause like a whole page to go off. I've done that a couple times.
Yeah, maybe you missed one, maybe you missed the last one. Or yeah. If you try to run like a scrap build, it should, give you some errors here. If you can try to read that, or maybe if it's not a lot of errors, if you copy some of the errors, maybe we can be able to help you in that case. But if not, you can share it in Discord and we can help you on that part. But why it's probably started to appear when you put on the lib is maybe the compiler did not register it before. So there were errors in the code, but it wasn't registered. So when you put in the lib, it is registered, but then there's the issue. I'm showing you that there's an issue with the code.
Olodele is also asking about why do we have to use a generic since we know what we use the contract state? Why the T in the trade? I'm confused.
You said, why do we have to use a generic since we know would use the contrast state? Why the T in the state? Well, we could use T contrast state. It's just again, it's a generic. It's up to you. We could use T contrast state. We could use T. We just use T because it's kind of like easier to type than T contrast state. But if we, write this in full, it will still work.
I think the answer is why do we need a generic at all? Doesn't matter the name. And the reason is because the contract state, the actual type, is not known right now. It's only known when the compiler goes through your code and compiles the counter. And that's what the actual type it gets created. But when you write the code, before it gets compiled, you just don't know. You have to define, hey, it's gonna be a type here. You're gonna provide the actual type later when I actually try to use the interface.
So you're saying the contrast state is not known. So it's like you're putting a generic until like we define it ourselves, and then the compiler would kind of like get it at that point.
Yeah, and you can name the generic T or A or B, doesn't matter the name. It's also gonna be a generic. So that's
Mhm.
why I put T initially, just to make it short. Let
Okay.
me see what more questions. Levi's asking, does the contract state have to be defined in a struct, just like you did in the example?
Yes. Does the contrast state? It has to be defined in a struct of storage. Or well, the convention is using storage, but it has to be defined in a struct. And it has to have this attribute of storage. This is again when we're showing you an example of like a bare bone Cairo contract or smart contract. We said we need to have a struct of storage for the compiler to even be able to compile it as a Cairo code. So this is essential to have for a smart contract to have a storage annotated with the storage attribute.
Joshua Sumare is asking, how do you print the counter object to verify the value? Is it possible to
Uh,
print it on the console?
it is possible to use debug, but once we kind of like deploy it, because again, we are trying to deploy it onto the and onto StackNet, we should be able to read it also from like the testnet or wherever.
Alberto's asking, what exactly does the touch counter.cairo command do?
Okay, this is a Linux. This is kind of like a bash. You just create it. You could, I could have like, created a new file here, and I just use a command line. So I just said touch. It could be anything. I could say, let me say this. So I could have touched class.cairo. Or it doesn't even have to be .cairo, but this is just a command to create a new file or update the timestamp of the file. And this is to remove it. But this is beyond the scope of Cairo. This is a Linux command or a bash command or a shell command.
Okay, no more questions.
Okay, awesome. 45. about to start events, and then we can talk about access control. Do you want us to take a break now, or should we just continue? Events is like a new concept.
We can finish events and then we take the break. What about that?
Awesome. Okay, I'm going to use an example from the Cairo book to show you all the events. Again, this kind of helps. If you're trying to use a new concept that you don't understand, you can just use the Cairo book as reference. So this is the Cairo book. And then we have like a section on smart contracts. And then there's the section on contract events. This will show you how events is defined. So we have this event here, and we have the derived drop StackNet event, and then it's an enum with different variants. And then we can copy and paste this. We can just copy and paste this and edit it to our taste. Second. Okay, so go back into this space, and I can just paste the events here. And I'll just remove these. So in ours, we want the contract to emit an event once the counter is increased or decreased. So we can call it maybe counter increased event. So yeah, the counter increased event, and it's again a variant. I'll just use the same name here, counter increased. And then I will get counter decreased. Counter decreased. Username counter decreased. And again, if you want to learn more about what an event is, you just go to the Cairo book. You should be able to read that events are ways for contract to inform the outside world of any changes that occur during the execution. Again, the example here, and you can read more about how it's implemented. But yeah, anyways, we kind of have the variant of events that we want in our contract, and then we can have like a struct that shows that. So we have like a derive attribute here. So a derive, and in this place we have a drop and a StackNet event. And yeah, we can implement that. So struct and the counter increased. And then we put in what we want. And in this case, we just wanted to kind of emit a counter event, which is a U32. So U32, we wanted to emit counter once it decrease increases. Copy this. And once it decreases, when it's the same thing, so just counter decrease. And in our contract here, this is where the emit is. So it's self.emit. Again, we can just kind of look at the example here. It should show you, yes, self.emit and the event that we want. So I can just, again, just copy this and come here and paste it and just modify it. So in this case, it's counter increase. So just copy that, put it here, and then the value here that we want it to, which is going to be the new counter. We can do the same for the decrease. So just copy this again. And once it decreases, we want it to emit a counter decrease. Just get this and do this. Then I'm going to run a quick scrap build just to make sure that everything is still working fine. Okay, now we have an error here. So missing member, a new. The workspace increase does not take a new counter. Give me a second. So in this case, we have a self.emit counter creased.
What's the name of the property in the, if you go to the enum for the counter increase, how do you call
The
the
counter. We call it counters. We just need to state
exactly.
it here. And then we call it here counter. Then we should try to run again. Finished. Okay. It's still throwing an error. So in this case, expected U32, and I'm getting this. Okay. Counter increase, counter. Yeah, this is registered, yeah.
Yeah, I have a question also. Oh, yeah, in the increase counter,
Yeah.
are you saying that the function self the counter the right returns a value? I didn't know that.
You said what?
And line 51,
Line 51, yeah.
that function returns a value?
Yes, I think it does return a value.
I don't think so.
Oh, you don't think so? Okay,
No.
I'll try this then. And now just do a self dot counter dot right. Then I'll put the new. So if it doesn't return a value, it makes sense why it is erroring out. We'll cut this and I'll paste it. So just paste it here. Then you counter. Okay, this should get it now. So scrap it. Okay, that worked. So self dot counter dot write doesn't return a value; it just writes to the state. So that's what's the issue here. But yeah, we do have the contract built in fine. So that means it should emit an event at once increase counter function is called by an external agent or another contract. And if you do a decrease also, it should also emit the counter decrease events once that is going on. Okay, Martin said it doesn't. Okay, I think that is showcasing the get counter, increase counter, decrease counter, and reset. So next thing we're gonna do is kind of use like a component, but I will take a 10 minutes break before that. I think we're at a good checkpoint right now.
Yeah, sounds good.
Before the break though, if anybody kind of got lost, you can ask questions now, but you can also give a thumbs up to show that kind of you're following.
Well, Chinaus is asking, can we interact with a smart contract with something like Remix?
Starknet doesn't currently have Remix, so you would probably want to use like Explorer, or you can use Stackline, or I think there's another tool, Cast, SN Cast, that you can use to interact with it. But we don't have Remix that you can use right now.
No, we do have a plugin for
Yeah.
Remix.
We do have a plugin for Remix. I've never
Yeah.
used that. Okay, so see, there's a good answer. Yeah, you can use Remix. Says Sandra also.
You can use Remix, but you have to enable the StarNet plugin.
Okay. Oh, see, I'm learning something new. I actually never used Remix to interact with Starknet. I know Remix you can use with Solidity. But yeah, you can use Remix, just install the Starknet plugin, and you should be able to interact with it that way. And you can deploy and invoke functions on Remix with Starknet, David?
You can what, sorry? Interact with functions?
So can you deploy and interact with functions with it?
Yeah. You can do it all. I'm not a fan of Remix, to be honest, but you can do it all if you want to. You give it a try.
Yeah, I'm also not a fan of Remix. I'm like, just do it if you can do it. Yeah. But yeah, it's probably a good way to also get started. But yeah, we'll take a break right now. So when we come back, we're going to, try to introduce access control, and then we set up our Stackline, because right now we do have it installed, but we don't have the configuration setting. So we're gonna do the access control. We set up Stackline, and then we take quiz. I'm going to shift my screen and get us a countdown timer, and put it 10 minutes.
Yeah.
Awesome. All right. So yeah, the next step, we're going to try to show you how to use like external contracts from libraries. And this example, we're going to use, Open Zeppelin access control. So we have a new, package registry called scarps. And in this case, we can come to the registry and find a library of contract we want to use, and we want to use Open Zeppelin access control. So if you go to scarps.xyz, I'm going to leave the link here. You will find Open Zeppelin access. And in this case, we want to install this. So if we copy this and go to our contract, if we go to scarp.toml, we'll see under our dependency, we only have StarkNet. But if we run the command scarp add Open Zeppelin access control or access, it should add Open Zeppelin access to our dependency. Just going to download it and add that. And then we want to just go to the documentation to learn more about Open Zeppelin access. In this case, we can go to access, and it should tell us that, access control and the things we want to use it for. In this case, we want to kind of ensure it's kind of security. It's kind of, yes, part of contract security. In this case, we want to ensure that we, have an owner in our contract, that only owner can, call certain function. You will see the example of the usage of the Open Zeppelin owner here. So this first one will show you that, you can import, Open Zeppelin access control, and you will get a component. I remember during the theoretical part of the class, we talked about components and how, we can build reusable code, similar to a contract, but this one cannot be declared or deployed, but can be added to other program. So you can see the code behind owner. Yeah. So StarkNet components, which, and then it's a module with this ownable, and then it just has like storage, also events and implementation. But we don't need to write this code. We can just kind of plug this into our contract, and that's what we're going to do. So we going to import that. So we copy the importation command there. We go to library, and then we'll put it. I'll just put it here.
Okay, can you show the command again to add this dependency?
The command, I'll just go back to scarps.xyz and I'll paste it. So in here we have Open Zeppelin access. Just copy this, put it here. I just left the command in chat.
Yeah, thank you.
Awesome. Okay, so go back here. We copy this. And we paste it here. I'm going to try to go a little slow so that the person that asked that question can catch up. So while you're doing that, I'll just show you the component. Again, we have...
Can you increase the font size of this? Yeah.
See it?
Thank you. Yeah, good.
So yeah, in this case, we have, again, component. This code cannot be declared or deployed, but can be plugged into code, and that's what we're doing. We have the StarkNet component. You see that, yeah, again, pub mod, so it's a module ownable, and then it also imports other code here, which use get caller address and the storage too for write and read. And then it imports interface. You see, in this case, they have like interface secluded from the main code. So interface is in another file, and they kind of implement all the interface that's needed, and they're importing it into this code. Again, because we are writing a simple code, we have everything in one, but you just kind of, again, use this to learn about how other people are writing code. And Open Zeppelin is like an industry standard. They actually do contract auditing. And so you can, learn a lot of the patterns that they're using to build from reviewing their code. But anyways, I hope the person I'm waiting for already caught up. So we have the ownable implementation. We can look more into the example. You'll see that they have a mix. They have like ABI embed. They have components here where they are bringing this into scope. So this is a component macro, putting the path to the ownable, which we just got. And then they have storage, bringing the storage from the component and the event into the scope of the code. So we can put this here. So component, path, ownable, component, storage, ownable, and event. That's we're not done. We need to still copy this code, which is the storage. We're putting our own storage, so we can just copy this and paste in our storage. We'll do the same for the event. So again, you will see ownable events here. So we'll copy this and paste it. I'm just going to come out here. And it shows that it has an initializer. So we have to initialize the owner of the code. So copy this and we'll paste it here. But that's not all. We still need to copy this and paste it. Again, this is just in the constructor. We're trying to initialize the owner of the code. So owner, which is a contract address. Then the ownable component has an initializer function, which is also for a function that should run once. So in this case, we're initializing owner when the contract is being deployed because the constructor is going to be ran. But yeah, and you ask where is the owner? The owner is coming from this storage, which is from the ownable component. But that's pretty much it. We have like the logic that we need into for me, this ownable mixing implementation, if you look at this, it has, if you can just ownable mixing, you will see it has like the function owner, transfer owner, renounce owner, and then it has a camel case. Maybe you don't like it, maybe you like it. I like to use like maybe a two-step. And the two-step is, well, the two-step includes like so when you want to transfer ownership, you just implement that you are not just transferring directly. You have to kind of like request the transfer. And all this, you wouldn't even need to, implement the logic. You can just copy literally this and paste it. So you copy this. So I'm going to modify this. Okay, I actually don't have that implementation block on my code. So I'm just going back here and put this mix in because this is where we're implementing the functions of the component. So I'll just take this and I'll paste it here. And I want, let's just use the defaults first and then I can change it again and then we'll see the change. But in this case, we have like the mixing, which is just like the ownable functions, but also like the regular Cairo style. And also we have like the camel casing. And when I deploy, we're going to be able to see that example. But this is pretty much using the ownable component. So we also want to kind of like enforce that maybe only the owner should be able to reset counter, right? So in this case, we can go find maybe the assert.
Before we go there, okay, I think could you maybe summarize the steps for the component again? I think people got lost.
Okay.
Like it's like a review again what happened there.
So for us to use the component, we first installed the Open Zeppelin access control. And then as a dependency, we import it. So Open Zeppelin access, ownable or ownable component. And we can find that like example here where it's imported. So we can just copy this code and put here for the importation. We need to bring the component by calling the component macro. So put the path to the component, so ownable component, and we're calling the storage too and the event. And then we implement the trait here. So this contains like the logic for the ownable mixing implementation. And this is the internal implementation. So in this case, you're bringing the functions of the component into scope. So if you remember again, a component, you don't understand it. Okay, I'll try to explain it when I deploy it. But yeah, we're bringing the function of the ownable mixing implementation and the internal function into scope. If you remember what the component is, a component is kind of like a reusable or like a reusable code block that cannot be deployed. So it's similar to a contract, but we cannot deploy it. So it has its own storage and its own function implementation. So this is where we're bringing the function implementation into scope. We're importing it here. And then we are also adding the storage to our own contract storage here. And then we are adding the event also here. And we're initializing it. Did that help? And once I deploy it, you're going to be able to see it clearly. But is the mixing required? Excuse me. So we're using the mixing function. It is not necessarily required, but we need like a function type and the mixin, so enable mixin. Let me show you the interface. Maybe this will help. So again, interface showcase the function signatures, right? So with the mixin, let me see, enable mixin. Okay, there's no interface in here. Okay, let me go back here and find the mixin. So what it is, it's taking the enable interface. So it's just mixing the two interfaces together. So it's giving us the enable interface and the enable camel. So it's kind of mixing two interfaces together. That's why it's called a mixing. But it's just exposing functions that we're going to be able to call in our contract. So it's exposing owner function, which is exposing the transfer ownership function, the renounce ownership function, and then transfer ownership camel function. And this is why it's mixing. It's mixing two interfaces together. I don't know if that clarified it. And once I deploy the code, you should be able to see it more clearly if you're a visual learner. Okay. Okay. Is there any other question regarding that, or are we good? Okay, good. Answering question. I don't see any question. Okay, I'm going to copy this. This is the function to assert only owner. So I'm just going to add this here. And what it means is that it's going to run this to assert that, okay, is the owner of the function, which we kind of initialize here. And then if it is, the owner, then it can call the function. If not, it cannot. Okay. Okay, I'm going to run a scar build right now. See if this builds fine. Okay, this build's fine. So we have used the, Open Zeppelin access control here. Next thing, I just want to add like some error handling in the code. So I'm just going to add one error. I am actually just going to copy the implementation of this error here, and I'll paste it and explain it. So this is kind of like a mode for error. And we define a constant negative counter, and we put in a felt here. We're going to use an assert to call this. So we can use an assert to check, and then we can call the function. So I'm going to do that maybe trying to see where I should put this at. Maybe in decrement. So we should not be able to decrement if it's 0, right? So I can add the assert here. So we can do an assert here. Yes, it's ERT, assert, and check old counter. And this is the value of counter here that we read from the control state. So we can just compare it here. If it's greater than 0. So we just saying assert if it's greater than 0. So if it's greater than 0, it's fine. But if it's less than 0, you should throw an error. So in this case, we can just say the error one is a negative counter. So assert here and throw a negative counter. If you don't want to do it this way, you can as well also just copy this because it takes in a felt. You can just copy this felt. I just put it here just to modularize it here, but you can also do it this way. Yeah, and I use an assert function instead of assert macro because it's cheaper. If you use a assert macro, it's also going to work, but you have to use a byte array at that point. But I would rather use this because it's cheaper. And I don't have to use the macro. So that's pretty much it. And this case, we're just asserting. So we get a value. So if the old counter is greater than 0, it's going to be fine. Then the function will continue running. Else, it's going to panic. and it's going to throw this error that, hey, it is, less than 0. You should not be able to reduce more than that. I think I'm going to run a scarp build right now and see if it's fine. If it's fine, we're going to set up the stack line, and then we'll try to declare and deploy. Okay, so, okay, I need to put in this. Yeah, missed that. Okay, clear. Then we run a scarp build, and this should build fine. And then we set up stack line, and we should be good. Okay, so I ran the scarp build is fine. So we have written our contracts. Now we want to deploy it onto the stacknet. One tool that we can use is called stackline. So if you do a stackline.h, you should be able to kind of like get what is. So stackline is a blazing fast CLI tool for stacknet, stacknet powered by stacknet RS. But you can see this is the usage, and this is how we want to use it. But in our case, we need it to declare and deploy. And you see this declare contract class and deploy a contract using the universal deployer contract. So first up, before we need some configuration. The first one is to set up a signer, because we need a signer, and then we need an account to be able to declare and deploy a contract. So we do a stacknet signer, key store. Before I do that, let me see where I am at. I'm in this. I want to move back to my root. So if I do this, just gonna check. Scarp.log. Okay, this is the root directory of my project. I'll just do a pwd to see. Okay, cool. Okay, because we're using a component, a container, I'm going to put the counter in the project root directory and git ignore it, because if not, every time we restart our container, we have to reset the configuration, and that can be a pain. So I'm going to go back and do this. So stackline signer, and then we'll do a key store, new key store .json. So this is going to be where our key store is going to be stored. I'm going to copy this command and paste it. So we set the password here, so you can put any password. I'm going to put a password I use. Now, so you see the new key store file is created. I'm going to paste the command if anyone wants to follow along. Obviously, you should try to not show anybody your key store, but think of it as like your private key. Yeah. So we created a key store. Now we are going to create an account. So there's another command on stackline that we can use to do that. I know the first day we use Argent or Bravos. We can also do that, but this is just an easier, faster way. So I'm going to do a stackline account. I'm going to use an Open Zeppelin, so OZ, and then an init, and then I'll call it an account.json. And then we have to pass in our key store. So we'll say key store. And then because the key store was created in the root, so it's just going to be key store.json. And then put in the password you set. Okay, so now it's created a new account. So you see an account, and the key store is created. I'm going to copy this command again and also post it in the chat. So anybody that wants to follow along. Okay. So with that, we have an account here. For us to deploy the account, we will need to fund it. So I'm just going to copy this, and I would send some test Ethereum there, so we can use to fund the account and deploy. So login, I'm already on Sepolia. I'm going to send some Ethereum to the account. So in this case, I'll just show 0.0.01. This should be enough to deploy. So send some Ethereum there. Again, Stacknet is fast, so you should have received it. So yeah, I'm just going to run this command, stacklet account deploy, and I'm going to also pass in the key store again, key store, which is key store.json. And yeah, I'm supposed to set up my Stacknet RPC, but because I did not set one, it's just going to go to Sepolia and default. So I'm going to use the default because I actually want to use the Sepolia. So I'm going to just do this. And this should tell me that I need this amount of it to deploy. So I'll do this. And yeah, my account is deployed. And this is pretty much all I need to set up my Stackly. And now I'm going to try to declare the contract because we ran a scar build. I'll just run it again. It should build the contract. And then it should create a file called target and dev, and then give us some API here. I'm going to use this. So I'm going to be a Stackly declare and then target dev. I'm just going to go with this. This should declare the contract. Okay, I need to pass an account too, because I've not set that environmental variable. So it's account, this is COUNT, which is account.json. And then I'll pass in a key star, which is key star.json. And it's, again, tells me I've not set the RPC. It's going to fall back to Sepolia, which is fine. So I'm going to do that. Okay, so this is going to declare the contract. We get a contract class ash, and then we can deploy that contract with the class ash. So if we want to do that, we can still use Stackly deploy. We'll put the class ash, and now we're putting the constructor argument. So in this case, we have two arguments. We have the initial value and the owner count. So I'm going to put the initial value. Let's just say I want to start my counter at 4. And the owner account, I'm going to set the owner to this account. So we'll just come here and paste it here and then paste that. Again, because I've not set the account environmental variable, I need to just pass an account and key store. So I'm just going to copy. Yeah, I'll just copy this and I'll paste it. And this, again, asks for my password. And with this, we should be able to deploy the contract to StackNet Sepolia. So it's deployed. You'll see the transaction hash here, and you'll see the contract address here. So let's just quickly check that. So we go to a StackNet Explorer. And if we go on stack scan.co, we should be able to check that. Okay, I'm trying to check on mainnet. Obviously, it's not there. So I switch it back to Sepolia and put this. So you see that the account was received, it's pending, and it's accepted on L2. If I copy the address, I should be able to see the address. Yeah. Okay, then we should be able to see the functions here. We have a get counter. Remember, I set it as 4 when I was deploying. So it's 4. The owner, I set it as this address. So this is the owner of the account, OX07, so OX78, and it ends at A9. So this has been able to declare and deploy. And anybody around the world, again, can use this. So if I send this to you, you should be able to check this, paste it. You should be able to check this on your, and you should be able to write to it. So right now, I'll just need to connect my account. So I connect with Argent. I should be able to increase the counter. Remember, I initialized it as 4. If I'm trying to call it now and invoke it, it should, and I check it right now, it's going to be 5, right? But then you remember that I only set increase counter, decrease counter, reset counter. But then you're seeing transfer ownership, renounce, transfer ownership, camel case, and renounce ownership. This is what is coming from the mixin that you're asking about. So we have these functions exposed from the components that we imported. This just helps us to transfer ownership and renounce the ownership. Again, if you check the owner here, it says I'm the owner of here. I can transfer the ownership to anyone. So if anybody was following along and, or I have an Argent account and on Sepolia, I want to check it, I can transfer the ownership to you. Just drop your, contract address in the chat, and I'm going to do that. While I'm waiting for that, let me just check. Okay, while I'm waiting for that, you know what? I'm going to, okay, we check this again. This is 5. If I try to reset, so if I run the reset function, I obviously need to be connected. If I run the reset function, remember the counter was 5 last time. If this works well, because I'm owner, I can call the reset function. Once I transfer the owner away, you'll see I cannot call the reset function again. But if you check now, the counter is 0. Okay. And if we try now to decrease the counter, let's connect. And we try to decrease the counter in this place, it's going to throw an error. It's going to be like counter cannot be negative because we had a error set here that counter cannot be negative. So yeah, in this case, we just abort and then we can increase. I'm just going to increase it to 1 and transfer the ownership and try to reset. So I've increased it to 1. I'm going to transfer the ownership to Abraham. So just transfer the ownership here. Right. Okay. So I'm no longer the owner of the account. So if we go to the read again, we check the owner, you see that it's not 0x78. It says 0x78. Okay, wait. Give me a second again. I think maybe I did not run that properly. I'm going to transfer the ownership to Abraham. See. Oh, yeah. It says I'm not the owner. So it should not be 0x78. So let's run this. Yeah, it's now a different address here. So it's Abraham's address that is on here. So I am not the owner anymore. The counter is 1, but if I try to reset it now, I need to be connected. Connected. If I try to reset it now, it's going to say, oh, you're not the owner. You're only the owner can perform this action because we added the access control. Yeah. I don't know if that clarifies anything. Any question with what is going on so far?
Well, Bube is asking if you can go through the deployment process one more time.
The what process?
The deployment process.
The deployment process. Okay, awesome. This is what I'm going to do. I'm going to change this to a 2-step. Remember, we just transferred ownership 1 time, and I'm no longer the owner. I'm going to switch this macro, this component. So we have the ownable mixin. I'm going to switch it to 2-step. And again, this is just going to expose different functions that is packed with 2-step components. So I'm going to do this. I don't need to change much here, thankfully. So I can just do a scarp build. And we just walk you through the deployment process that way. So run a scarp build. It builds with no error, right? Next step would be to use stackline to declare the contract. Remember, every time you change the contract, the class hash changes. So we cannot just deploy from the class hash. We need to declare it again. So we're going to declare stackline declare target, dev, and we just do SN workshop. It's this one with the class hash, contract class hash, the JSON. So we will go with this. Okay, it's throwing an error because again, I've not set the environmental variable. So I just need to put account. So account flag, and I'll put an account.json because we created the account and key star. So I'll put account.json, so account.json, and then do a key star, and a key star.json. And then it's going to tell me that, it's going to be Sepolia by default, which is fine by me. So just put in my password I set when I was creating my key star. Then it's going to declare the contract and create a new class hash, right? Then we can now do a stackline deploy because we've declared the contract. We'll use the class hash, paste that. And then if you remember, in our constructor, we have 2 arguments that we need. We have initial value of U32 and an owner. So I'm going to set that right now. So the value, let's just set by default value to be 23, just because, and then we'll set the owner to be my contract address right now. So copy this and I'll paste it. Then again, it needs me to set the account and key store flag. Normally I have this set up in my environmental variable. I'll show you how to do it if time permits. I think time will. And you should be able to see this. Now we should be able to deploy. So we've deployed the contract that way. I don't know if that answered your question, but if you want to confirm that, again, we can just copy the transaction hash or the contract address. We can check it here. Again, your stack scan need to be set in Sepolia, but we can just run this. Okay, so again, it says it's accepted on L1, so that's a good thing. Again, StackNet is very fast, so it takes seconds to accept on L1. Okay, now we have it here. Now we see we have get counter, we have owner, and we have a pending owner. And then we have increase counter, decrease counter, reset counter, accept, excuse me, accept ownership, transfer ownership, and renounce ownership. Excuse me, I'm gonna drink some water. So because we changed the component from a mixing to a two-step, it introduced new function. And one of the function is the accept ownership. So right now, it's a two-step transfer. So if you transfer the ownership, it's not just going to automatically transfer until the person you transferred it to accepts to be the new owner. But again, we can still do the same thing. You know what? I will first check the value, which is 23 because we said that when we're deploying to be 23, yeah. And if you check the owner again, I am the owner. If you check the pending owner, it's going to be a zero address because there's nobody. I'm going to reset this now. Reset it. So the counter will go to 0. And I would transfer the ownership. But once I transfer the ownership to, let's say, Diego sends his address, I will still be considered the owner until Diego accepts to be the new owner. So I call this and I'm transferring ownership. With the first one, I'm no longer the owner. But if you write check right now, it still says I am the owner. Then when you check the pending owner, it gives you Diego's address. So until Diego accepts that, okay, I want to be the owner, I am the owner. That's just the difference between this one. And yeah, I can, try to decrease the value because I reset it to 0. I should not be able to. So just go here. Reset this. Well, I already reset it and I'm still the owner, so I can until Diego says, he wants to be the owner. But I cannot decrease it because of the error boundary we set. Yeah, it cannot be negative because it's 0. That's pretty much the deployment. Did everybody follow along or are there any questions right now?
A question from Diego. I suppose we can use our own wallet address. In this case, we created a new account to deploy it. In the hard hat, you will use the private key or mnemonic and variables. There are similar end variables for Cairo, I suppose.
Yeah, you can use your own agent wallet address. I just did not want to expose my, private key. But I also kind of like using OZ. But if you go to the documentation, StackNet documentation, so start docs.stacknet.io, it should show you the steps on how you can use your own, your agent address. I think it's under this place. It's not here. It's going to be setting up your account. But yeah, it shows the steps. So yeah, you're going to kind of use your key store here. And then you're going to fetch the address from Agent or Bravo. So I'm going to leave the link in the chat if you want to do that. But I just have noticed that, using an OZ account, it just feels more convenient. And if you set up the environmental variable, right now I'm passing it every time. It's just going to be passed by default. I'm going to check on time. We have about 22 minutes left. And we need 10 minutes to answer the quiz. So we do have enough time. I'm going to try to show you how to set up, this environmental variable. And if you do that, you just go to theme. Well, I should have written a script, but I didn't have enough time. But if you set it up locally, you can use theme. Just go, I think it's your zhrc file. And you just set up a StackNet. Give me a second. Let me find that my hand so I can write the right thing. So it's gonna be this. Okay. So we need to set up our RPC, which is going to be Sepolia. So I'm going to put that here. So this is, I'm also going to paste it so that everyone else can follow along. And we need to set up like our account. I'm going to paste this, and then we need to set up our key star. Copy this and paste it. This is obviously not where the path is, so I'm just going to save this for now and go get the path. So I'm just going to pwd. This is where the path is stored. I'll copy that, and we'll open my vimrc again and modify this. So, okay, interactive. Paste it here. I'll do the same here. And you can also just export it. You know what? That would have been easier. You can just export in your terminal, but yeah, we can just do this. I'll just save this, and then I'll just source the shrc. So source it. So if you kind of echo StarkNet account, so you have the path. So next time I want to declare, I don't need to put, so I can just do a starkly declare, and then the target dev and the part. I don't need to put the, I don't need to put my dash that account or, the RPC or the key store. It just knows, so it's just more convenient to just declare and deploy. So again, because it did not change, the class hash is the same, but I can declare a new contract. So I can just do is the starkly deploy, and then put the contract here. And then again, initial value. This is what we want to use as initial value, and the contract address. Yeah. And then I don't need to put again account and key store. So just set that to your environmental variable and you'll be good. Again, you can have like a script that does that. And yeah, you put this in your root and just ignore it. And so you can push it, and then you will still be able to work on your project. And you don't have to do the setup every time. So that's pretty much that case. Are there any questions before I go on to resources and quiz? Are there any questions, concerns? Try to look. Was any other person able to deploy their contract? I couldn't control the code. Yeah, I deployed mine. Awesome, Diego. Any other person deploy their contract? Oh, yay. Yeah. Oh, yeah. I should show you the events that I also, had in mind. So, we created some custom events. So every time, this was the ownership transferred. Okay, so this one I probably did not increase. Give me a second. I'll try to increase and see. Oh, sometimes it takes a minute. So yeah, he has this event counter increase. So if you check this, I probably had some issues with the index. Okay, yeah, it's, we had this event set up that every time, we call the increase counter, it should emit an event, which is counter increase. And if we call the decrease counter, it should emit another event. So let's see what the counter is here. So it's 1. So if we connect this again and call the decrease counter, okay, it should also emit another event. It takes like a few seconds for the blockchain to index that, or this explorer to index it, not the blockchain. But once it indexes it, you should also see a counter decrease. function here. So again, and these were events that, we're part of the components that we imported. But yeah, I think that's pretty much about it. And congratulations, Diego, for deploying your contract. I don't know if it's your first time. But yeah, is there any other person that deployed, or is anybody that has a question?
Looks like we're
Okay.
doing well. We only have 50 minutes left, so what about we go to the quiz? Okay, or there's something else you want to discuss before the quiz?
There is nothing else before the quiz. They're just resource. I'm going to, show that resource, and yeah, we can go to the quiz. Give me a second. Okay. Yeah, and these are just resources to learn more on Cairo. So there's the StackNet book, Cairo book, Foundry, Stacklight, and there's like the StackNet by example. So if you want to see a lot of like example code, you can just come here. And again, if you're looking for applications that you can build on StackNet, this project that's maintained by Nethermind kind of shows you some of the things you can build with a contract. So this, yes, it token vote, the DeFi vote, shows you example of upgradable contract. So if you kind of, want to get your feet wet or dirty, you should definitely come around and check other contracts that exist on StarkNet so you can get some inspiration. The same thing with the Open Zeppelin, contract library. They have a lot of libraries that can help you. And so instead of you, having to write everything yourself, these are library of codes that are reusable. They are almost all components here or, presets. You can get this here. This governance, you can, read the API. You can go directly to the code base, and then you see example of how this works. But yeah, that's pretty much it. I think we can go on to the quiz.
Right. That is the end for today's session. Thank you very much, Okaya, for all your effort, and Casey for the support as well. Any further question, please go to Discord. We can help you there. Then we will provide the link to recording tomorrow, most likely in the morning. And please, when you close the Zoom webinar, you're gonna get a feedback form just to know how we did it. Especially it's valuable for us and for Okaya as well to know to improve for the next session and for future Basecamps as well. Thank you very much for all in attendance. We actually had a bigger crowd than session 1, and that has never happened. That's pretty cool. Thank you, and bye-bye.